Hi, I'm AnsibleGuy. Today we'll talk about what Ansible basically is and how you can use it to manage your systems. First of all, I'll talk about what kinds of management interfaces Ansible provides. After that, I'll talk you through some key points that I personally think are important regarding Ansible. Then we'll talk about what kinds of systems you can manage using Ansible and how Ansible is able to connect to those. And as a final topic, I'll talk about scripting versus automation. So comparing scripting-based solutions against automation-based solutions like Ansible. I'll talk about features that I personally think make a solution like Ansible superior to basic scripting-based solutions. And to finish it off, I'll show you an example that compares a Bash scripted solution against an Ansible-based solution. So let's get into it. The documentation of what I'm going to talk about can be found linked down in the description below. Alright, what interface types does Ansible provide? The core Ansible interface is a command line utility. That one is open source and free to use. How does it look like? I'm going to show you. It looks like that. So in that case we are executing a Ansible playbook, so the executable is Ansible playbook. And what are we executing? We are provisioning the configuration of a Nginx web server on the host proxy02. Like you can see, first it asks me for the connection and become password, and after that tasks are executed. So you can also see what tasks were executed, what tasks were skipped, and if something changed, if a task changed some configuration or some setting, you can see it as changed. Also, if you are providing the difference flag or enabling the difference mode, you can see what changed. In that case, the group ownership of that file changed. This command line utility, as I said, is the core interface of Ansible. The other two interface types we are going to talk about use this command line utility in the background. So, what are the other interface types? The other two interfaces are web-based interfaces, so you can use them through the web browser, but you have to install a server component for them to work. So this one is just a pretty basic installation. I've covered it in my previous video, how to install this command line utility. The installation of the next two interface types is a little complicated. A little more complicated. Not too complicated, but you know what I mean. Alright, how does such a web interface look like? It looks something like that. This is Ansible AVX. It's also open source and you can use it for free. It's a web interface where you can run Ansible playbooks. The basic workflow of using Ansible is still the same. So you write Ansible playbooks, you write Ansible inventories, and this interface can execute them for you. You can also manage user privileges, what user can run what tasks and so on and so forth. You can also schedule tasks so they run timed every few hours or so, something like that, and have a little nice overview of what jobs have failed, what, how many hosts are you managing, and so on. The last interface type is Ansible Tower, or it's now called Ansible Automation Platform. It basically looks like, the interface looks like Ansible AVX, basically, but it has some more functionality and is an enterprise grade development of Ansible AVX and Ansible Core. So that's the basic idea behind Ansible automation platform, so Ansible Tower, it was called before. Admins write Ansible playbooks and Ansible inventories, and as you can see, the Ansible command line utility is used in the background. And after that, users can use the web interface, so they don't need to know what exactly is done by those Ansible playbooks. They maybe just provide configuration for those playbooks that is checked for validity somehow, and then they can execute those playbooks. For example, admins write a playbook to provision a new web cluster or whatever, and a developer or somebody from, from a management team can add a new cluster and press the button to provision it. So it empowers users to use those specific automations in a simple way. Yeah, and it has many more extensions you can use. I will not go into every detail because I personally haven't used Ansible Tower or Ansible Automation Platform, the web utility, so I won't go into it too deep. But that's how you can use it. Also, as I said before, in the documentation that's linked down below in the description, you can find links to all of those interface types, links to downloads, links to documentation of Ansible directly, so you can read it, everything about it if you'd like to. Alright, that's all about the interface types of Ansible. We'll go to the next topic. Alright, let's talk about some key points about Ansible that I personally think are important to know. We'll go through those using my online documentation. That's what we talked about right before. What practical examples of Ansible use cases are there? I've added some of those here. You can provision or manage IT services from small up to large scale, so it's really no difference for you from an administrative standpoint if you are managing 2 nodes or 200 nodes. Maybe the management behind it is a little different, but the provisioning doesn't really change. Yeah, for example, you can provision web server nodes, database clusters, configuration of host and network firewalls. That one is very important in my opinion, because those, especially if you are managing hundreds of host firewalls, you should keep the rules up to date somehow and consistent across data centers and so on. It's a little hard if you don't automate stuff. Yeah, also you can, of course, configure local users or even identity providers. A really nice use case for automation for Ansible, in my opinion, is certificate management. So generating, renewing certificates, either using ACME, Let's Encrypt, for example, or internal certificate authorities. So you can use encrypted connectivity. In today's world, IT world, no one should really use unencrypted connectivity, even in an internal network. And automation makes it so easy to generate or to request certificates, to sign them. It's done in a few seconds, and you don't have to think about yeah, many things. Of course, monitoring is needed, so those certificates don't uh, yeah, run out of lifetime without you knowing it. But that's off topic. Also, what's a nice use case for automation is disaster recovery. So you have already prepared tasks, playbooks, configurations to reset your whole infrastructure and start from the bottom up, restore databases, restore web clusters, whatever you are using. Or if you're using Microsoft Windows, you really should have a disaster recovery plan in that case. Then you could, for example, add users to Active Directory using automation, or manage group membership using automation. So if you have to start your Active Directory from the bottom up, you can just press enter and all those permissions are back in place. Alright. Next up, why should you think about automating IT administrative tasks? Some points were mentioned before, but the most important points, key points, are listed here. First of all, scalability. Like I said, it doesn't really matter for Ansible, for your execution, for your provisioning, if you're targeting 2 or 200 servers. It scales very nicely. Also, you can implement your infrastructure as code. You can read about it in the link. Those benefits are of infrastructure as code: cost reduction, speed of deployments, reducing errors. You can read it yourself. Also, what's very important in my opinion is having your configuration in one place and versioning it, so you know who changed what configuration of what system, and system configurations of can reference each other. So Linux or network firewall configuration can reference a host firewall configuration, and maybe you can even reduce the amount of manual configuration you need, because you have duplicate configuration in your infrastructure, and you can just reference it that way and import it in some sense. Yeah, abstraction of the administration tasks. Like I said, with the web interface of Ansible, that's all about it. Just press one button and whatever is done in the background, you'll see if it failed or if it ran through it. That's it. Yeah, it can also be implemented or added to your CI/CD workflow or to provision or deploy your software, whatever you need. And what's really nice of Ansible, in the case of Ansible, you can also automatically test your playbooks or your roles using a testing framework. So, for example, if you're using a Linux system, Debian 11 right now, for example, and you want to upgrade to Debian 12, you can just say, molecule, let's test all my roles on virtual machines or containers with Debian 12 instead of 11, and let's see if there's some version specific errors occurring. So it makes upgrading a lot easier and a lot less frightening, so to say. And also, if something changed, those playbooks and roles change every day, because that's what admins are doing if they are working with those automation tools. You can use those the testing framework to find errors. They happen. We are all humans. We all make errors, but they should be found before they hit your infrastructure hard. That wouldn't be so great. Yeah. Now to the last key points regarding Ansible. First of all, Ansible is designed to work in an agentless manner. So you don't have to install any package, service, or software on your target system. Because of that, you, of course, have few to none requirements on your target systems. I'll talk about the requirements a little more in the next topics. Yeah. Why is it good to be agentless? Some other automation frameworks have the need for agent installations, and that's another service, another package to maintain. So you have to constantly update, upgrade those packages, and if you don't have the package pre-installed on the system, you cannot manage it. And of course, those services need, most of the time, need admin or root access on the target system. So if some security issue occurs regarding those agents, you have a problem on your hands, a pretty big one, if you have agents running all over your infrastructure. Alright, to the next point, Ansible is designed for its operations being idempotent. So it's always checked if an operation is needed before it is performed. Sometimes you have to implement that idempotency yourself on a task level, but most of the times Ansible modules already have implemented that functionality, so you don't have to think about it. It's also very nice that Ansible is designed to use host and group configurations, so multiple configuration scopes, and you can template tasks and roles with those. So a role can behave differently for different hosts or groups and so on. I'll go into that a little deeper in the comparison between scripting and automation. Yeah, and last but not least, it's designed to verify that the target state is as desired. So it's if you are, for example, copying a file from your controller to the target system, it checks if not only if the file exists, but also if the file content is the same, and so on and so forth. Yeah, that's about the key points. Next up, we will talk about what target systems Ansible can target. Ansible target systems. Ansible can basically target most of infrastructure servers and devices. You can address you can target Linux or Unix-like servers, cloud providers, Windows servers. You could, of course, manage Windows clients, but I've not seen that. I wouldn't know if that's practical, but you could do it. You can manage network devices like switches, firewalls, VPN configurations, for example. Also, storage devices, databases, virtualization platforms, monitoring systems, and many more. You can click through those links, as I said, in the documentation down below. You can check it out for yourself if you are interested in some of those target systems. Also, third-party contributions allow you to target even more devices. For example, I have created an Ansible collection or Ansible modules to manage OpenSense firewalls, network firewalls. Yeah, that's all about the target systems. Next up, let's go through the connection types Ansible can use or is using. Ansible can use different connection types for different systems as they are needed. The most common one in my experience is SSH for Linux or Unix-like systems, and also for network devices like switches. Some other network devices have already implemented APIs and they are used instead. Cloud services and many other systems like hypervisors mainly use HTTPS REST APIs to be managed. And last but not least, Windows systems are managed using the Windows Remote Management Protocol to execute PowerShell scripts in the background. Now I'll show you this picture that describes how the execution of Ansible modules differs between network devices or API endpoints and Linux or Windows hosts. On Windows Linux hosts, the module code the modules are copied to the target system, executed on the target system, and after the execution are removed from the target system. Of course, if there's no way to copy modules or execute modules on the target system, you need to execute them locally, in that case for network devices or API endpoints, and the modules that are executed on your controller environment are communicating with those devices or API endpoints to make the changes or don't make the changes. However, it looks there. All right. Also, to just quickly talk about it, there are some advanced tricks you can use for letting Ansible connect to systems that you cannot directly address. For example, using SSH tunneling. So you're addressing one public server and want to manage the whole private subnet behind it. You can use it as a jump host to reach that private subnet. Also, Ansible provides a functionality called automation mesh. I'm not sure if that only is provided to the enterprise grade Ansible Tower, Ansible automation platform, but the feature is there. You can configure or add proxies that are used as jump nodes for your Ansible management connections. Alright, that would be all about the connection types. Next up, scripting versus automation. For those of you that have some experience using scripts or scripting to automate your common daily tasks, I'll go into how automation tools like Ansible compare to basic PowerShell or Bash scripting, per example. First of all, Ansible has more overhead than basic scripting and is a little slower than just executing scripts, but that has its reasons, and I'll go into the features that Ansible provides and why it is a little slower and why that is a good thing. First of all, many of those features help you prevent mistakes and or errors, and also make the workflow, the usability of the framework or the automation tool much more enjoyable, I would say. First of all, a very important point, Ansible is made or is designed to be as simple as possible. Ansible playbooks, roles, tasks are written in YAML syntax. You see it later on in the comparison. This format makes it really easy to read and understand what's going on, and even people that don't have that much experience in the administration field or have practical programming or advanced scripting experience can understand and even write the most basic tasks. Of course, when it comes to complexer systems and complexer tasks, templating, you need a little background info on how to use for loops, if, else, and so on, and variable scopes. But I'll talk about those topics in some future videos. I've already planned those. After that, Ansible provides a check and a diff mode. Ansible check mode is a very nice feature. You can execute any task or any playbook in check mode, and it will not change the state of the target system, but show you if the state has changed and if so, what changed if you also activated diff mode. Sorry. Yeah. That's pretty nice to have, and also nice to have if you are developing new roles or new playbooks, just to test out if they are working like you would expect them to. Then the diff mode, like I showed you in the CLI example before, the command line example before, the diff mode shows you what changed, if something changed. That's pretty good information to have if you're debugging something or just want to have verbose output. Ansible also has built-in error handling on module level. So if you tell Ansible to copy a file from your controller to the target system, there's a lot of checks and error handling already going on in the background inside of the module, just to make sure it's not breaking anything. And if the module fails, it's already most of the times a soft failure. So your system most probably will not be impacted negatively if the module fails. It just tells you there's something wrong. Go fix it. And also those modules most of the time will return you useful information whenever they fail, just in case you want to handle those errors differently or whatever. You have the information available, you can use it. Ansible also has validation of parameters, so every time you call Ansible module, those parameters you are specifying are checked. If you're specifying a parameter that is not required or not expected by the module, it will fail. It will tell you that's unexpected, please fix it. And also if you are providing some variable or some parameter to a module, its type is also checked, and if it can't be converted or it's unexpected, it will also throw you an error. So you can't kill your system with that easily with just providing wrong parameters. You'll see it in the comparison example later on. That's not the case for basic scripting. You would have to implement such a validation on your own every time, or it's a lot more complicated. All right. Secrets. Secrets are a big part of infrastructure management. There's many times you will have to specify some secret key or value, copy, certificates, or whatever. Ansible has already built in functions to work with secrets, with passwords and so on, with sensitive data. So you can use Ansible Vault to store sensitive data encryptedly on your drive or wherever, and it will be decrypted on runtime. Also, Ansible can use third-party vault solutions like HashiCorp. That way you would even have a solution where your administrators or your automation engineers, would call them, can't really read the secrets they are using. Then Ansible will also protect passwords and sensitive data, or can protect data from its logging using the no log parameter. Also modules that allow you or need you to specify a password or a key or something like that will also set this parameter for or set this property for the parameter. So it's already set as no logging parameter in the module's context. And also you can have prompts on runtime, and also the value of those or written in those prompts can be stored encryptedly. And another very important functionality of Ansible is the configuration handling. Ansible can work with multiple configuration scopes, with configuration on host level, on group level, on role level, on execution level, playbook level, and some more. I'll let it stand that way. Yeah, Ansible, like I've written there, handles this mind-boggling logic in the background, and you don't have to deal with it actively. You need to understand it basically, but you don't have to care about it. All right, that's about the major features that I think are making Ansible a superior solution to basic scripting. And in the next topic or the next chapter, I'll tell you or I'll show you an example of how Ansible compares to bash scripting. What am I showing in this example? I tried to create some basic server setup. In that case, a web application that needs a MariaDB database server, an Apache web server, and that will configure Apache 2 modules and set a Apache 2 virtual host, so a web server config. Also copy a MariaDB database configuration, import a database if the database is not yet imported, create database users, copy the web application, and add a systemd timer to update some data on the schedule. The prerequisites that would have to be met on both are written there. You can read it if you'd like to. So let's jump into the bash example. First of all, I'm no bash professional. I've used bash to create scripts that are used in production, and bash has its place, of course. Bash scripting has its place. Many times when I want to run a script on a schedule on a target server using a systemd service, a systemd timer, I'll use a bash script because it's working, it's all that I need. But in this example, I'll show you that it's not really made for automation like that. First of all, this script would need to be executed on the controller node, and therefore we have to supply some parameters, the target IP, port, and user. In that case, we already have a problem. That is, if one would specify those parameters in a wrong order, it won't work in the best case, in the worst case, it would yeah, make problems. Of course, one could validate those parameters or let them be supplied using flags or another way, but yeah. Now some constant configuration. There we set the bash execution types. We'll say it should fail on whenever something fails, so don't keep running if one single task or one single command fails. Fail if undefined variable is used, and fail pipes. If one command in a pipe fails, fail the whole pipe, so to say. Alright, changing the directory to work in the correct relative path scope. After that, I am creating a shortcut for SSH and for SCP, a function to copy a file from the local controller to the remote target, also a function to log or to display a message with the current time. Of course, all of those functions and that handling is not necessary in Ansible, it's already built in, so yeah. In that case, we're creating some temporary directories that will be needed with bash. After that, we will call SSH to the target server and install the components we need, enable the services, start the services, copy the configuration template from the local configuration directory to the local temporary directory. Here one would need to add some configuration manipulation. In my experience, most of the time one would use set to replace given lines inside of a configuration file if you're using bash. Ansible has built in a complete templating solution using Jinja 2 that makes this obsolete, but in that case, if you're using bash, you would need to make pretty complicated changes to the configuration file. After that, we will copy the configuration from the local temporary directory to the remote server and set its mode and owner group. After that, reloading the database server. Yeah, then we would check if the database is initialized. If not, import the database schema. So copying the database schema and importing it. After that, we would create some MariaDB users, and that's pretty much it with the database configuration. Now removing Apache default sites, creating the web directory, copying the app to the web directory, changing the owner and mode of the web directory. One could or should set the mode of the directories in this recursive path differently than on the files. One could do that with find, most probably, with the find bash utility or a binary. But in that case, I didn't do that here. I'll show you later on how easy it is with by using Ansible. Then we will copy the Apache configuration, set configuration from the config directory locally to the local temp directory. After that, you would also need to modify that file using set or something else. Then, of course, you could also manually edit the file, but yeah, however. After that, we'll copy the Apache site config to the target server, set its mode and ownership, enable some Apache modules, reloading the Apache service, adding the systemd timer, so copying the service file, the timer file, enabling the timer and starting the timer, and after that cleaning up. It would most probably work. Whenever you would rerun the script, you would most probably want to implement some checking if the local configuration and the remote configuration are the same, because then you won't need to copy it or reload a service or whatever. It's doable, of course, but I'll show you the example using Ansible and you will see why I would prefer it. In this example, I am using one or two collections that would be that you would need to install on your controller using Ansible Galaxy, like covered in the first video of mine on how to install Ansible. Then that's the host configuration or the inventory configuration. We are defining a server 1 and a group web app 1. In that group is also the server 1, but there could be more servers in this group. After that, the host specific variables are defined in the inventory host vars and name of the host.yaml. You see that is the YAML syntax. It's pretty easy to read, and in that case, if you are using an editor or an IDE that has support for YAML syntax highlighting, it's really nice to read and work with. In that case, we are defining the SSH or connection or parameters and some app-specific configuration. You can see the passwords of the database users are stored encryptedly right here. We didn't do that in the bash script because it would have been a little more complicated to encrypt and decrypt those. Also, the user privileges that should be set are set in the configuration. Then let's check out the playbooks or the playbook. I've added some play tasks. Here first the installation. Here we explicitly tell the playbook just execute those tasks on servers that are in the group web app 1, because if some new employee or something else would execute this playbook by error on any other host, and you would write all in there, then it would install the app1 components on that target server. In that case, that would be the case, because we have limited the execution scope to that group. That's always good practice, just to prevent mistakes. Also, we have to say become is true, so the commands or the modules are executed with root privileges. First of all, we are installing the packages. After that, starting and enabling the services. It's pretty easy to understand what's going on and nice to read. And after that, we are managing the database. We are copying a template, a Jinja2 template configuration to the destination. So this configuration file can already have host or group specific configuration in it, and it will just be templated on the its templating tags will be translated on the run, so to say. Also, we are setting the ownership and mode of the configuration file. Here we also say we want to have the mdb conf variable set, and this variable has the information stored in it what happened in this task. So if we say reload the service only if the config changed, it's just that easy and completely logical if you read it, isn't it? After that, we are executing a MySQL query to the database as configured. Let's check if there are some tables exist in the configured database. Register the variable mdb empty and copying the database schema and importing the database schema if the table count is 0. Looks a little complicated, but actually it's really not. If you used it one time. The first time is a little funny, but yeah. So the database schema here is also just imported if the database isn't initialized. And to finish the database configuration up, we are creating MySQL users, allowing the connection from localhost, so no remote connections for those users. Setting the password as set in the configuration. Also, that's this password. This word content will be decrypted when we run the Ansible playbook. So here, in that context, it's already the real password, so not the encrypted value. Let's say update password only on create, and do that with all the users that we have defined in the users, the pay users. So if we want to add another user or change the user privileges, we just need to change it in the configuration and don't even have to touch the playbook. Alright, after that, the Apache 2 web server configuration, removing the default sites as seen in the bash script, copying the web application data. Here you can also see the directory mode of this recursive copy is explicitly set to another mode than the file mode. Also owner and group are set here. Then we will copy the ginger2 template.config to the site config, register a2 config as variable, and reload Apache if the config has changed. And to finish it up, we are enabling Apache modules. I see right there I have forgotten something. Of course, I would need to register another variable here, because whenever you enable Apache module, you will also have to reload Apache or even restart it. I think reload is enough, but yeah, mistake on my end. Can also happen. And to finish it up, we are creating the update service, adding the systemd timer in service, also a ginger2 templated file, and enabling and starting the timer. Also here we have the update service name inside the configuration. And that's how you would execute it. Ansible playbook, some flags, define the inventory you want to use. In our case, we have an Ansible Vault encrypted variable inside the configuration, so we want Ansible us to ask for the password to decrypt those. Then the playbook we want to execute, and in this case we limit the execution to the server 1. Here are the flags, diff mode, asking for the become, connect password, inventory file, and so on. So you'll have to build your own opinion about what type of automation or what type of scripting you would personally like more. In my case, I would 100% of the time say I would prefer Ansible before Bash scripting or PowerShell scripting, because it has so many great features that are explicitly built for automating and for scalability, for managing IT systems. It's the right tool for the job. As I said, Bash and simple scripting will always have its place, but I think it's not inside of this kind of automation, not inside of automation for whole infrastructures. Yeah, as I said, it's an opinion. You'll have to build your own one. So, that's pretty much it from me about the intro to Ansible. I hope you enjoyed it. If you missed some information or you think something more would have to be added to this tutorial, please feel free to comment or create a GitHub issue on the repository, so I'll look into it. Or you have found some error, some wrong information. I'm no Superman, so that could happen. Alright, if you enjoyed it, hit the subscribe button, you know how that works, and keep automating. Goodbye.